Well, students, today we are going to discuss the description of Laplace transforms as well as the description of the properties of Laplace transform and the problems based on these properties. We have already discussed first Laplace transform property, that is a linearity property. According to this property, a Laplace transform is said to be linear if for every pair of functions f1t and f2t and for every pair of constants c1 and c2, we have one special type of relationship, that is a Laplace transform of constant c1 function f1t plus constant c2 function f2t is equal to constant c1 Laplace transform of first function plus constant c2 Laplace transform of second function. So this is the description of first property of Laplace transform, that is the linearity property. So we have already proved that a Laplace transform is said to be linear if for every pair of functions f1t and f2t and for every pair of constants c1 and c2, we have this type of special relationship, that is the Laplace transform of c1 f1t plus c2 f2t is equal to constant c1 Laplace transform of first function, that is Laplace transform of f1t plus c2 Laplace transform of second function. There are so many problems based on linearity property of Laplace transform. For example, you can calculate the Laplace transform of 3 t raised to power 4 minus 2 t raised to power 3 plus 4 e raised to power minus 3t minus twice sine 5t plus 3 cos 2t. Such type of problems, such types of questions you can solve by using the linearity property of Laplace transform. Similarly, sin t minus cos t whole square, you can solve it by using the same property. Similarly, another question is t plus t square plus t cube plus twice sine 3t. So such type of problems, such types of questions we can solve with the help of linearity property of Laplace transform. Second property was first translation or shifting property. And the statement is, if fs is the Laplace transform of function ft, then fs minus a will be the Laplace transform of e raised to power at ft. That is, Laplace transform of ft is equal to fs. Then we can prove Laplace transform of e raised to power at ft is equal to fs minus a. So according to this property, if fs is the Laplace transform of any function ft, then fs minus a will be the Laplace transform of e raised to power at ft. We have already proved it. There are so many questions, so many problems based on this property, that is first translation or shifting property. For example, e raised to power at t raised to power n. This is the first problem and you can solve it by using first translation or shifting property. Similarly, e raised to power at sine bt. Again you can solve it. In the similar way, e raised to power at cos bt, e raised to power minus at sin bt, e raised to power minus at cos bt. So such type of problems you can solve with the help of the second property of Laplace transform, that is first translation or shifting property. Similarly, we have discussed second translation or shifting property. According to this property, if fs is the Laplace transform of ft, then new function gt, which is ft minus a for t is greater than a, for it is 0 for t is less than a. In that case, Laplace transform of this function, that is gt, will be equal to e raised to power minus as fs. That is, if fs is the Laplace transform of ft and a new function gt is equal to f t minus a for t is greater than a. It is 0 when t is less than a. In that case, we have proved that the Laplace transform of this new function gt will be equal to e raised to power minus as fs. We have proved it. There are so many properties based on this property of Laplace transform, that is a second translation or shifting property. For example, you can calculate the Laplace transform of e raised to power t sin t. Similarly, cos cube t. So there are so many problems based on these properties, and you can solve it with the help of this property of Laplace transform, that is second translation or shifting property. Then we discussed change of scale property. According to this property, if fs represents the Laplace transform of a function ft, then Laplace transform of f at will be given by 1 upon a fs upon a. That is, if Laplace transform of ft is fs, in that case Laplace transform of f at will be equal to 1 upon a f s upon a. We have already proved this property. There are so many properties, there are so many questions, there are so many problems based on this property. For example, calculate the Laplace transform of L f2t. Calculate the Laplace transform of f2t if Laplace transform of ft is equal to s square minus s plus 1 upon twice s plus 1 whole square s minus 1. So if Laplace transform of ft is s square minus s plus 1 upon 2s plus 1 whole square s minus 1, it is given. Then you can calculate the Laplace transform of f2t. So this problem is based on the last property of Laplace transform, that is change of scale property. By using this change of scale property, you can solve this problem. Similarly, if Laplace transform of ft is equal to 1 upon s e raised to power minus 1 upon s, then we can prove Laplace transform of e raised to power minus t function f3t is equal to 1 upon s plus 1 multiplied by e raised to power minus 3 upon s plus 1. So if Laplace transform of ft is 1 upon s e raised to power minus 1 upon s, in that case we can prove Laplace transform of e raised to power minus t f3t is equal to 1 upon s plus 1 multiplied by e raised to power minus 3 upon s plus 1. This we can prove by using the change of scale property, which is the last property of Laplace transform. So there are so many questions, there are so many problems based on these properties. By using these properties of Laplace transform, we can solve various types of questions and problems. Thank you.